Okay, so we are putting these back together. So when I look at this one, we've got this minus log of something. Okay, that looks like what we get from the quotient rule. So this is log base 2 of 64 over 4. Okay. They ask us to write it as a single log. So that is a single log. Log base 2, I could go farther. 64 divided by 4 is 16. So that equals 4. What do we raise 2 to in order to get 16? The answer is 4. Okay. Yes. Yes, you could have done that as well. Um, but in this case, the point was to practice the condensing. Okay. All right. 4 natural log of x plus 7 natural log of y minus 3 natural log of z. Okay. Yes. Okay. Okay. All right. So you put a lot of steps together. I'm going to write it out in a few more steps just so that we are clear. Okay. So we got natural log of y to the 7th. Okay. Minus natural log of z cubed. So we used the power property or undid the power property. And now we do natural log of x to the 4th times y to the 7th over z cubed. And I want to be clear, it's the natural log of all of that. Okay. Okay. Questions about that one? That's why did I group them together or when? I mean that's what we were working towards the entire time, but I was able to group these together because this had a plus right here. So that meant I can multiply, and then this one was minus a natural log, so I was able to divide. And that's z cubed, not z times 3. Okay? Now number 11 is a little tricky. We got to be careful because we had those double minuses. Um, what I want to do is I'm going to group those together. They will end up on the bottom, yes. Okay. But we got 1/3. This is, I could say, log of x plus 1 squared. Okay. And then what I'm going to do, just to maybe try to make this clear, is factor out that minus. And so we get minus log x, x, plus log of x minus 3. Okay. I could factor that minus out. So now in parentheses, okay, we still got the 1/3 on the outside. This is log of x plus 1 squared minus, this piece is going to become a what? What we have here in parentheses. Okay, it's a product, right? So log of x times x minus 3. Okay. I didn't have to have that extra set of parentheses, but okay. And so now we could see that this is going to become a what? Working backwards. A quotient. Okay. So same thing. 1/3 log x plus 1 squared over x times x minus 3. You could, but no. Now you can't write x squared plus 1 because that's not, remember we got to do x plus 1 times x plus 1. You got to FOIL it, okay? Could you write it out? You could, but there's no reason to, okay? We like things in factored form, Factored form is good. So this is already in factored form. I wouldn't multiply it out. Okay. All right. And so the final step, you could, but there's no reason to. Okay. Because I factored the minus. When I drop this parenthesis right here, um, this one right here, I had to factor out these two minus signs. So I took minus from here, it became positive, and I took minus from here, it also became positive right there, right? So, if we were to go backwards, if I took this minus and distributed it to each of these, we'd get minus log x minus log of x minus 3, right? So when I factored it out, I did. And the reason I did that is because when you have those multiple minus signs like we had in the original problem, it's like, well, do I divide and divide again? I'd rather just kind of put them all together as a product. And then this minus sign right here says I'm going to put that whole thing on the bottom. Uh-huh. Yes, and finally we take the cube root. All right, so we got log of the cube root of x plus 1 squared over x times x minus 3. All right. Yes, Danny. If you no, I wouldn't, as long as you did it right. Now, if you did it wrong, then okay. All right. But chances are you may see some multiple choice stuff, so you need to be able to recognize your answer. Okay. All right. Other questions? Okay. Very good. All right. Okay. Where are we? Is this where we are? Oh, okay. I think we were right here. Evaluating logs using the change of base formula. Okay. So we know how to evaluate logs if they're base 10 and we're taking the log of something that's power 10. We know how to evaluate natural logs if we're taking natural log of something that is a power of e. And even if it's not a power of e, we've got buttons on our calculator that will do that, right? We know how to do log base 2 of things that are powers of 2, just like we just saw with the log base 2 of 64, log base 2 of 16. We can do that in our heads. But what if I said log base 2 of 10? Okay, the calculator won't help me, right? Because there's no log base 2 button on the calculator, and I can't do that in my head. Um, so we have what we call a change of base formula, where when you have a log of a certain base, let's say 2, I can change it to an equivalent expression in base 10 or natural log. And then, of course, we use our calculator from there. So how do we do that? Okay, log base b of x equals log base a of x over log base a of b. So I could change it to any base. A could be any base, all right? But this would give me an equivalent expression. Now, what bases would I change it to? Either what? Either E or 10, because I got calculator buttons for that. So this says this is equivalent to log of x over log of b. Or, if you prefer natural log of x over natural log of b. All right, so how do we analyze this? In our original statement, b is our what? In this original statement, b is the what? It's the base, right? And notice that b ends up on the bottom, right? Okay. And then log x, that's what we're taking the log of. Where is that? It's on the top. right? And you can change the base to whatever it is you want, okay, as long as it's the same top and bottom. So our old base, that's going to be on the bottom, and the thing we're taking the log of, that's going to be on the top. The base, well, you can take the make the base of this new thing whatever you want. They have to be the same, okay? No, they're not exponents. No, B was a base. Now B is what we would call the argument. It's the thing we're taking the log of. All right, X was also an argument. It's still an argument. We're still taking log of X. We're just using a different base now. Okay, so it's as long as you remember the formula, that's what's going to be important. Then applying it is not so bad. So if we have log base 3 of 13, can't do that in my head, right? And I don't have a log base 3 button on my calculator. But what I can say is that this is equal to log of 13 over log of 3. Okay, I've changed it to a base of 10, which we do have on the calculator. Or you could have said natural log of 13 over natural log of 3. Okay, so let's do it on the calculator. Okay, so on my calculator, I'm going to say just log of 13 divided by log of 3, and we get that. Now, how can we check this answer? Do what? That's right. If we raise 3 to this answer, we should get 13. So 3 raised to, I'm going to do second in the negative key to pop in that previous answer, we get 13. Okay. Okay, let's see what's going on with you. And possibly you can try B. I'm going to pause. Okay, so our answer for this was 2.335 approximately. Okay. Okay. All right, so what if we had log base 6 of 10? I could rewrite that as what? Okay, log 10 over log 6. Okay, and just do that on the calculator. Okay, very good. Yes. All right, so 1.285. 1.285, what comes after the 5? A 0, so 1.285. You could, or you could say 1.29. I would probably use at least 3 decimal places. Okay. All right, let me do it on the calculator just to be sure. So we said log 10 over log 6. All right, so yeah, I'd call it 1.285. All right, I mean, since that next number is a 0, just go ahead and don't even mess up the rounding, right? So 1.285, but 3 decimal places is pretty good for us to use. Okay? All right, we got log base 1/2 of 2. At first that might look scary, but doesn't matter, right? I could rewrite this. Let's use natural log this time just because. It's the answer is going to be the same. So if you already did it, that's fine. But how would I write this out? All right, very good. Natural log of 2 over natural log of 1/2. Mm. The answer should be the same whether you use natural log or um, log base 10. Okay, we got some problems. Let's see. Okay, let's do it on the calculator. Use a decimal where? You should, yes. Okay, well, let's see what. I got -1. That's the right answer. Okay, questions about that? All right, very good, very good. Okay, let's see. Okay, you're okay? No, as long as you're clear. As long as you're clear. Um, but this one is interesting. Let's talk about this for just a second. Um, yes, we're going from 1/2 to 2. What do I raise 1/2 to get to 2? We got to do that. But also, let's look at this. Now that we got some new rules, we got natural log of 2, okay, over natural log of 1/2. Yes. Let's see how this is going to work out. I'm thinking natural log of 2, okay, over natural log of 1 minus natural log of 2, right? Isn't that my property for uh, quotients? Now, I can't do it here because there's already a natural log on the top and the bottom, but I can do it to the 1/2. And natural log of 1 is what? Nope. Nope. Try one more time. 0. All right, so we get natural log of 2 over 0 minus natural log of 2. It's -1. -1. So now that we know some more properties, we could have, easily, well, somewhat easily done that by hand. All right, so for tomorrow, you got a quiz that you're turning in on 3-4? Is it on 3-4 or 3-3? 3-3. Okay, that makes more sense. Tuesday. All right, and those dates are posted in Schoology. Um, so work on some of this 3-4 homework as well, and I will see you tomorrow.